In this release, we have a new product to announce, Solid Edge 2D Nesting 2020. This product has many benefits to the user, including continuous improvement nesting, easy nesting of solid edge files, the most efficient nesting process, and return on investment that is very high based on material cost. Let's get started. First, we'll do a selection of part files that are the same. In this particular case, we're looking for part files that are made of 304 stainless steel that are 14 gauge thick. Now, let's start Solid Edge 2D nesting. We can start Solid Edge 2D nesting either from inside of Solid Edge or as a standalone application. Let's bring in some Solid Edge files. These files are sheet metal files that have already had a flat pattern created for them. That's another great benefit of this product. There's no need to save DXF files manually. The progress bar lets us know that this work is occurring. Another benefit of Solid Edge 2D nesting is that it can extract data from PSM or PAR files. That means it can handle lots of different types of industry requirements. Solid Edge 2D nesting has analysis tools to help us do our job. Each file has an indicator. Let's take a look at the yellow flags. That part's okay, but this part has a real problem where the edge of the sheet metal part has been chamfered. We'll discuss this with the engineer, but for now, we'll remove it from the list. The last file has a very small notch in it. That could be a problem, but for a water jet machine, that's okay. Solid Edge 2D nesting doesn't limit us to just Solid Edge files. We can also open DXF or DWG files, and they can be combined into the same job. Once the data is in Solid Edge 2D nesting, we can do analysis like what is the longest part and what is the widest part to make sure they'll fit on our water jet cutting machine. We plan to build 2 of our WashTec machines this month, so we need to double the quantities. For a few of the items, 2 are required for each machine, so we will make 4 of them. For the last few items we pulled in, we have been waiting for a 304 stainless 14 gauge job to run to make them, and we need 6 of those. Another great benefit of Solid Edge 2D nesting is that it can incorporate multiple sheet sizes. This is something that other nesting programs cannot do. This results in much less wastage, as we will see later. We are now ready to begin the nesting process. We can either run the process for a fixed amount of time or let it run until we stop it. Let's go. We see results immediately, but we also see the constant improvement process in action. Each nest is more efficient than the last. Notice how the product is using different sheet sizes? That is extremely important because it means that the tailings, which are sometimes called leftovers or partial sheets, will be kept to a minimum. Have you ever walked into a shop to see all of the leftover sheets? Too small to use, but too big to throw away. These leftovers are the bane of inventory management. Solid Edge 2D nesting will help you reduce that problem to a mere memory. The graph above the nest shows the current efficiency and the time it took to get there. Unlike other nesting programs, Solid Edge 2D nesting shows you not only the current most efficient nest, but also others in case you wish to go back and try one of those instead. After we stop the nesting process, we can look at the individual nests that we've created and choose the one that best fits our needs. We can even examine details such as where individual parts are placed inside of each nest. Now we will select the nest for export back into Solid Edge. Notice that I'm choosing a nest with a very small leftover. That's so we won't have that leftover sheet stock problem in the shop. Now, export to Solid Edge. We will export the sheet outline and output all the data into one file, although we could have each nest as a separate object in Solid Edge. We can also export the data into a DXF or DWG format if you need that. Because these are all PAR files, we can use synchronous technology to take the sheets and convert them back into solid models. Let's examine one of the files now. Here you can see that it is 2D sketches arranged in a part file. Since these are all valid sketches, we can very quickly use synchronous technology to create solid models from them. Solid edge nesting works with solid edge files, but also neutral data formats like DXF and DWG. It automatically extracts the required data and is a very efficient nesting algorithm. Quickly export your data into a solid edge format or a neutral format. You can also nest into multiple sheets, which reduces the tailings or partial sheets. All these factors combined give you a return on investment that is very high.